See that little dot in the back? Okay. So we're starting off with order of operations. And there's that special word that goes with order of operations. Anybody remember what it is? PEMDAS. Do you know my son, he's in 6th grade, they don't use PEMDAS anymore. They use a different acronym. What I think it starts with a G. Yeah, I think they call it maybe GEMDAS, like grouping, exponents, multiplication. Yes? Is that what you learned too? Do you have a younger sibling?
No, she mentioned it, but we use this one.
Okay. I'm like, I don't want, it's PEMDAS, don't change it. So I'm scared for the group that comes in and they're like, it's not PEMDAS anymore. All right, so we're PEMDAS. The P is for parentheses, E is exponents, M multiplication, division, addition, subtraction. And parentheses, exponents, absolutely first. But then remember, it's multiplication or division, right? And addition or subtraction. You don't have to add before you subtract. You don't have to multiply before you divide. It's sort of whichever one comes first there. So let's just do some examples. We have 6 plus, open your brackets, 13 minus 4 times the quantity, open parentheses, 18 minus 9, close those parentheses, close your brackets. Okay, so according to PEMDAS, what are we doing? We're looking at our parentheses first. I have multiple sets of parentheses because the brackets count as parentheses, right? I think that's why they changed it from P to G. I think it was G, anyway. They just mean anything that sort of groups things together, meaning the parentheses. So we have the brackets, we have the parentheses. So when you have multiple pairs of parentheses, you go from the innermost parenthesis first. So I'm starting here. We're going to go 18 minus 9. So we are 6 plus 13 minus 4 times 9, close your brackets. And I honestly think, obviously, this is an Algebra 2 class. This is like pre-algebra. It's not that hard, but students still make mistakes because I think you just go through things so fast and don't check yourself. So a lot of students at this point would subtract the 13 and the 4. And then multiply that product by 9. You don't want to do that, right? Multiplication before subtraction. And if you make that mistake, it's usually just because you're not thinking. You're just like sort of going too fast. So here, we cannot subtract 13 minus 4 because within that bracket, you have subtraction and you have multiplication. So you have to do the multiplication first. So we are 6 plus 13 minus 36. We're still working within our brackets. So now we are 6 plus, and then 13 minus 6 is a negative 23, which could just end up being minus 23. And then 6 minus 23 is a negative 17. All right, I'm going to give you 2 to try on your own. Sorry, that negative 8 divided by 4 is in parentheses. This. Who needs another minute to finish up? Okay. All right, I want you to compare your answers with somebody next to you. See if you guys got the same thing. All right, how many people got the same thing as their neighbors? Oh, not many. Okay, tell me some answers you got. For number 2, once you simplified this down, what did you get? What's your name? Abby, okay. Okay, did anybody get any other answers? We got a -16, yes. We got 0. Did anybody get a different answer? -36. Did anybody get a different answer? Okay, what about number 3? What answers did we get? Tell me some answers. I'm not telling you which one's right. Antonio. You got a half. Did anybody get a different answer from a half? Everybody got a half for number 3. Nobody got anything different. Okay, a half is correct. Good. Anybody want to see me do this? Anybody want to see me do number 3? Don't be shy. Okay. So we'll do number 3, then we'll go back and do number 2 because clearly we got many answers for number 2. All right, so we'll start with number 3. All right, we're following PEMDAS, we're working with our parentheses. The brackets count as parentheses. So within these brackets right here, we are working inside. I see multiplication and subtraction and division. So remember, according to PEMDAS, it's multiplication or division first, then the subtraction. So that's exactly what I'm going to do. So I'm going to go through this. We have 4 times 6, which is 24. Then we have that minus sign. Then we are at -7 times 3. Well, -7 times 3 is a -21. But then we have -21 divided by -1. Divided by 2 plus -1. Okay, so now I'm going to keep going here. So now we have subtraction and we have division. Based on our choices between subtraction and division, because we're still inside the parentheses, we are dividing first. We have to divide first. So here we're going to have 24 minus -21 divided by -1. Double negative makes the positive. And then we're divided by 2 plus -1. All right, now let's keep going. So now we have 24 minus 21. I'm still in my brackets. That's 3. We are now out of our parenthesis phase. We've now eliminated all our parentheses for groupings. So now we have left division and addition. So we have to divide. When I have 3 divided by 2, what I decided to do is I just decided to make that 3 over 2 plus -1. Now, what might be simpler, you might say, okay, well, 3 over 2 is just 1.5, right? Or let's say you didn't go that route. Let's say you you said, okay, well, I want to deal with fractions. That's fine. Deal with the fractions. So now we're 3 over 2 plus -1. We have to make a common denominator in order for us to be able to add this in fraction format. What is my common denominator? My common denominator is 2. So I'm going to make -1 into a denominator of 2. So you multiply top and bottom by 2. So it's a -2 over 2. Now you add. 3 plus -2 is a -1. You keep your denominator the same. Oh, positive, not negative. And there we go. Okay, so that was number 3. In the back, were we good? Okay. All right, going on to number 2. We got a lot of answers for number 2. Let's see. So again, I'm starting off with my parentheses. So I see those square brackets. Within those square brackets, I have parentheses within the brackets. So normally it's multiplication or division. I'm working within these parentheses first. So I'm going to divide -8 and 4. So we have 10 plus -8 divided by 4 is a -2. Then we want to multiply that by 4 plus 6 divided by a -1/3. So I'm still working within my brackets. So now we have -2 times 4 is a -8 plus 6 divided by -3. So now what we have is addition and division. We have to, according to PEMDAS, we have to do the division first. So we have to work on this. So here I have 10, I'll just make that a minus, 10 minus 8 plus, and now I'm sort of going to just group this together so you can see what I'm doing. 6 divided by -1/3. This is what I'm focusing in on right now. Remember, when you're dividing, what's the rule? Keep, change, flip. Remember elementary school? So we are 10 minus 8 plus 6, keep the 6, change the division to multiplication, flip it. So it becomes a -3. So now we are 10 minus 8 plus, or I should say minus 18. Now we just go from left to right. 10 minus 8. Oh, what did I do? Did I do something wrong? This is not 3. What's 6 divided? What's... Oh, no. Okay, I thought that was a half. Good. Okay. So now we're going to go. So now we are 10 minus 8 is 2. 2 minus 18 is -16. Yes.
Yeah, I forgot what 10 minus 8 was the first time.
Okay. All right, guys. So now we keep going. Yes.
For pictures, should we be...
Oh, yes. For pictures, guys, you're in charge of your own time schedule. You just go. Anybody else leaving? You're good? Okay. Oh, okay. All right. Are we all good with number 2? We're good? So now what we're going to do is we're going to just step it up just a little bit. We're still like in pre-algebra phase, if we're being honest. Find the value if W equals 3, P equals -2, and M equals 4. Okay. First problem. Tell them to lift the handle up if they're trying to get in. Is anybody trying to get in? No? Oh, I thought somebody was struggling. All right, so we have WP minus P squared minus, open your parentheses, W plus 2M, close your parentheses, and then a 2 on the outside of that. right, first thing I'm going to do is I'm going to substitute in all of my values. So we're going to have W is 3, P is -2, P again is -2. Now look what I'm doing. I'm doing the -2 in parentheses, then squaring it. It makes a difference. If you don't have the -2 in parentheses, it's just squaring the 2 and then just leaving the negative there. So it would be, so -2 raised to the second power is 4. That quantity of -2 raised to the second power is 4, but if you just had -2 raised to the second power, no parentheses, that would actually be -4. So the parentheses make a difference. The whole value of P is -2, and that whole -2 is being raised to the second power. So then we're going to minus, open our parentheses. W is 3 plus 2 times M is 4. Right, yes, M is 4. Close our parentheses, and then there's a 2 on the outside. So now once I've substituted in all my values, now we're just working with PEMDAS. So I'm sort of just like working simultaneously, which you can do this as long as you're not adding or subtracting or multiplying before it does another operation. You can do multiple things at once. What I mean by that is I know I have to work inside my parentheses first, and I know I have to do exponents after that, but it's not, by me multiplying 3 times -2, it's not changing anything that's being squared or in the parentheses. Do you guys see what I'm saying? So it sort of just makes things quicker. So 3 times -2 is a -6. And then again, by me squaring before I do what's inside the parentheses, once again, it's not having any effect on the parentheses, so I can do that. -2 squared is +4. Now I'm working inside my parentheses. Within the parentheses, we want to multiply and then add, right? 2 times 4 is 8 plus 3 is 11. But now we're taking that 11 and it needs to get multiplied by 2, right? When you have a number and then parentheses and then a number, isn't that multiplication? So now I want to multiply. 11 times 2 is 22. And then we are 6 minus 4 minus 22. So -6 minus 4 is a -10. -10 minus 22 is a -32. All right, you ready to try one of these? All right, so now this time I'm going to tell you x is equal to 5, y is equal to 2, z is equal to -7. Oh, that was fast.
Yeah, we got there before a lot.
Nice.
Yeah, but they're he didn't have a card, so it would take a while.
Oh.
What do we do?
This is the next problem we're doing. All you're going to do is you substitute in the values and simplify.
No notes?
What do you mean, no notes?
We didn't have to write anything down.
There was a problem before this, but you could grab it from somebody. It's along the same lines. You don't really need to see it. Yeah. All right, I want you to check with somebody next to you. Are we still working? Yeah? Okay, sorry. Okay, now check with somebody next to you. See what you got.
I'm very well.
All right, how many people got the same answer as their neighbor? That is a very good sign. All right, tell me what you all get. 35. I also got that. Does anybody want to see me do this? Yeah? Okay. So we're going to plug in. So we are 5 minus 2 times negative 7 minus the quantity of negative 7 minus 3 times 5. Close our parentheses, plus negative 7 in parentheses squared minus 3 times 5. So now we simplify. We know we're working here first. 5 minus 2 is 7. I'm not 7, sorry. 5 minus 2 is 3. And then we're going to do 3 times negative 7 is a negative 21. And now I'm working inside these parentheses. So I know within these parentheses I have subtraction and multiplication. So I'm going to multiply. We'll just do 3 times, we're doing 3 times 5 is 15. So we have negative 7 minus 15. I'm going to just do this since it has no effect on anything else. Negative 7 squared is 49, and 3 times 5 is 15. I'm still working within these parentheses here. Negative 21 minus negative 7 minus 5 is a negative 22, plus 49 minus 15. So now we have all addition and subtraction, so we can really add in any order we want. This double negative, doesn't that make a positive? So we have negative 21 plus 22 plus 49 minus 15. Negative 21 plus 22 is 1. 49 minus 15 is going to be 34. 1 plus 34 is 35. We good? Okay, so now I know I'm moving at a real rapid pace. It's just because, like I said, this is way below Algebra 2, right, grade. So this is just sort of a refresher, as quick of a refresher as we can give you just to make it fresh in your mind. So now we're talking about solving equations. I'm actually going to change the problem I have because I don't like that problem. All right, this is what I'm about to say right now is such a big concept for later on when we get to other chapters that students are constantly messing up. So right now, this is an equation. What makes it an equation versus an expression? Sham?
The equations have an equal sign.
Good. An equation has an equal sign and a number after it. Right. Our process for solving this as an equation is completely different than, let's say, that wasn't there. If that wasn't there and I asked you to simplify this, what would you have to do if I asked you to simplify this and it wasn't an equation? What's your name? Julia? Angelina.
Yeah.
Okay.
Probably give a common denominator.
Good. Right now, if that equal sign wasn't there, if this was not an equation, the only way to simplify this is to make a common denominator. But that's not the case. It isn't an expression. It's an equation. So now, by me adding the equal sign and a number after it, we have changed this from an expression to an equation. And now we're not simplifying, we are solving. And when we solve, we do not want to make a common denominator. Does anybody know what we want to do when we're solving?
Put the x on one side.
Eventually, we're going to get the x on one side, yeah, but I'm talking about with the fractions.
Oh, your fractions.
Good. We clear the denominator. We eliminate the denominator. And the way you eliminate the denominator is you look at the two denominators. So my denominator is in 6 and 3. And you're really asking yourself, if I were to make a common denominator for 6 and 3, what would be the common denominator for 6 and 3? 6. But instead of creating that common denominator, what you're going to do is you're going to multiply every single term in this equation by whatever that common denominator would have been. Even on the other side of the equal sign. Everything gets multiplied by that common denominator. So now we're going to go through, we simplify. The 6's cancel. And then in the second one, what happens? 3 goes into 6 how many times? Twice, right? All right, I'm just going to rewrite out to you what we have left. So when these 6's cancel, do you all agree that's just an x there? And then I'm going to have minus 2 times the quantity of 2 minus x equals 60. Yes, we agree with all this so far? Okay. Big thing here. I think probably like 95% of you realize we have to distribute, right? But I'm not distributing a positive 2. What am I distributing? A negative 2. If you distribute a positive 2, not a negative 2, it's going to throw off your whole answer. That is a negative because of that minus sign. So that whole negative 2 gets distributed. So this is x, and then negative 2 times 2 is a negative 4. Negative 2 times a negative x is a positive 2x equals 60. Now we're on the left side, I'm combining my like terms. So I have a positive x and a positive 2x, which gives me a positive 3x. And now this is just a normal two-step equation, which I'm very confident you all know how to solve. I'm going to add that 4 over. And we are at 3x equals 64, and our very last step is to divide by 3. Now, I know this is mostly speaking to the freshmen here. I know in the middle school they love mixed numbers and decimals. Everything gets changed to a mixed number and decimal. In high school, we hate mixed numbers and decimals, and we only change them to mixed numbers and decimals if it's going to somehow make our life easier. Doing that math, it makes it easier, right? Right now, if we're just solving for x, we leave it improper. High school loves improper fractions. They must be simplified, but we leave it improper. So I'm looking at 64 over 3. Is there a number that goes into 3 and 64? No. So all we do is leave it as 64 over 3. Yes. All right, let's do another one. So now I'm introducing another type of bracket just for fun. I'm introducing the squiggly bracket. It's considered a parenthesis. So we have that squiggly bracket, 6 minus, open your square brackets, 4x minus 3, open your parentheses, x minus 2, close your parentheses, minus 3, open your parentheses, x minus 6, close your parentheses, close your square brackets, close your squiggly brackets, equals -7, open your parentheses, x minus 1. Close your parentheses. All right, you're going to do this one on your own. I don't know why teachers always love to talk outside of my classroom. I think we could all agree it's not like these problems are difficult. It's just you have to be very careful. It's all about the little mistakes that you can make. All right, who has an answer for me? Who has an answer? Joanna? I mean, Juliet? It was
Angelina.
Angelina. Okay.
I got 97/17.
97/17. Did anybody get anything different? Who wants to see me do this?
Oh, hold on, sorry. I got 97 thirds.
97 thirds. Did anybody get anything different?
23/20. 23/3.
23/3. Anybody get anything different? All right, should we do it? All right, let's see who's correct. All right, So here what we're doing is we are working within our brackets. We're distributing that -3, and simultaneously I'm going to distribute this -3. You have to make sure that negative's there. So we are 5, opening our brackets, 6 minus, open our square brackets, 4x minus 3x plus 6 minus 3x plus 18. I'm closing these brackets, equals, I'm distributing this, -7x plus 7. All right, let's keep going here. So now we have 5, and I have my squiggly brackets, 6 minus, and now I'm just sort of going to combine my like terms. We have 4x, -3x, -3x. A -3x and a -3x is a -6x, plus a 4x is going to give us 2x. You got it. And then we have +6 and a +18, which gives us a -2x, thank you, a +24, equals -7x plus, was this 7? Yes? Sloppy handwriting? Yes. Okay. Close these brackets here. All right. So now we're inside of this. If you lost your square brackets here, that might have messed you up. You need those square brackets because see how it's 6 minus this whole quantity? That minus needs to get distributed into those brackets, into that bracket. So that negative needs to go to the -2x and it needs to go to the 24. If you lost those square brackets and you just did 6 minus -2x plus 24, that might have thrown you off. So let's distribute that in. Oop, wrong one. And you're distributing a negative, not a 6. It's just the negative and then the brackets. So this is 5. I'm just going to change this to brackets. 6 plus 2x minus 24, close our brackets, equals -7x plus 7. So now I'm working inside these brackets. So we're going to have 5 and then 2x and -24 plus a +6 is a -18, equals -7x plus 7. Now I'm going to distribute in that 5. So we're going to get 10x and 18 times 5 is 90. Does that sound right? Yeah? Equals -7x plus 7. We're going to bring that 7x over, and we get 17x minus 90 equals 7. 17x equals 97, and x will equal 97 over 17. So we found our answer. Okay, very last thing I want to go over are literal equations. Okay, so here we're going to solve for y, starting off simple. So I have y minus 3 over x plus 4 equals -5. When you have literal equations, it means you have a whole bunch of different variables and you're solving for one variable in terms of the other variable. So I can say, solve for y in terms of x. Or represent y in terms of x. That means solve for y. All right, our goal, whatever you're solving for, it's whatever you're solving for, that's what you need to get by itself. So when it says solve for y, that means I need to get y by itself on one side and everything else on the other side. So this fraction bar is sort of a grouping. All right, nothing can be done with the top of the fraction bar until I get the bottom or the denominator of that fraction bar away. So I need to get x plus 4 out of this left side. Right now, do we all agree it's being divided? That fraction bar means division. So to undo the division, we're going to multiply it. So I'm going to multiply x plus 4 on both sides. And when I multiply the x plus 4 on both sides, this cancels. The x plus 4's cancel on the left. So now you have y minus 3 equals negative 5x plus 4. I'm going to distribute in that negative 5. So negative 5x minus 20. And our last step for solving for y is to add the 3 on both sides. And now we're going to have y is equal to negative 5x minus 17. All right, let's step it up a little bit. Okay, this is solve the terms of a, b, and c. So we're solving for y. Seeing if there's a more difficult one. Okay, last one. Solve the equation. So you're going to see me writing different sort of rules here or directions. Solve the equation in terms of r and y. And we'll explain what that means in a minute. Okay, are we ready for my explanation? All right, when I say solve the equation in terms of r and y, I'm going to look and I'm going to see how many variables we have. Well, we have r, we have y, what we don't have, and we have x. So whatever they're not saying, that's the one you're solving for. So when they say solve the equation in terms of r and y, that's basically telling you solve for that other variable that's not listed up there. So if I'm solving in terms of r and y, I need x by itself and r and y all on the other side. Does everybody understand that? Those directions? Okay, so I need to solve for x. I cannot solve for something that's in the denominator. And to be quite honest with you, I don't want to deal with fractions at all if I don't have to. So what I'm going to do is this is an equation, there's an equal sign. I'm going to eliminate the denominator. And don't get frazzled because the denominators are all variables. So I have an r, an x, and a y. The common denominator for r, x, y is r, x, y. That's the common denominator. So we're going to multiply everything by r, x, y. And when we multiply the denominator, everything by rxy, here the r's cancel, so you're just left with xy. Here the x's cancel, so you're just left with ry. And here the y's cancel, so you're just left with, I canceled the wrong thing there, didn't I? This is an x, sorry. The y canceled there. So this is Rx. Okay, so now what we want to do, this is where I'm throwing a little curveball at you. We want to solve for x, which means I need to get x by itself. But you guys agree there's two terms that have an x in it? So what you want to do in this scenario, whatever has an x in it, you're going to bring to one side. Whatever doesn't have an x in it, you're going to put on the other side. So I'm going to keep xy here, and what am I going to bring to the xy side? Rx. So how am I going to bring the Rx to the xy side? Subtract Rx. So here we're going to have xy minus Rx equals Ry. Are we good so far? Okay, now I need to just get one x and I need to get it by itself. I can't subtract these because they're not like terms. But what I can do is sort of look at this as a grouping together. xy minus Rx, if I group these together, I can pull out what? a GCF of x. I can pull out a GCF of x. And then I'm left with y minus r equals ry. Once I pull out that GCF of x, now I have the capability of getting x by itself, because this is x times this whole quantity. So to get rid of it, this quantity of y minus r, and if it's being multiplied with x, what's the opposite of multiplication? Division. So I can divide that whole quantity of y minus r on both sides. So x will equal ry over y minus r. All right, we are done for today.